Good morning, everyone. Today we're going to continue working on sequences. So yesterday we talked about how to determine whether a sequence is arithmetic or geometric. Today we're going to talk about writing formulas to represent each sequence. So before we start writing those formulas, we need to know a little bit of notation. So each term in a sequence is identified by its location in the sequence. So whenever you have A with a little 1, so A sub 1, all that stands for, it's kind of just common sense, is the first term. Then A sub 2 would be the second term. A sub 3 would be the third term. So just, you would keep going like this. This is the one that might be a little bit different. So A sub n. So if it has a little n, n just kind of stands for the word number. This is the nth term. So you can plug in whatever number you want for that n. So if you wanted the 7th term, you would plug in n equals 7. If you wanted the 10th term, you would plug in n equals 10, and then it'd be a sub 10. So plug in numbers for n. Okay, so just so that I can make sure everybody got that, if I had the arithmetic sequence 1, 2, 3, 4, and it kept going, this would be a sub 1, this would be a sub 2, a sub 3, a sub 4, because this is the first number, this is the second number. I know it seems kind of silly to go over it, but it's important that we know our notation. Okay, so let's actually look at what a recursive formula is. So using a recursive formula means that each term in the sequence is based on the previous term. So again, with a little bit of notation, we already discussed that a sub 1 stands for the first term. A sub n is the nth term, but you could also think of it as the current term. So whatever term you're trying to find is the current term. So this is the new one that we haven't learned yet. A sub n minus 1. So say you wanted the 7th term, you would plug in n equals 7. So if you plugged in 7 here, 7 minus 1 is 6. So all this means is the previous term. Okay, so here's how we write our recursive formula. Of course, we have two different types of sequences, so we're going to have two different types of formulas. So when it's arithmetic, they always have to give you the first term, or at least one of the terms. More than likely, it'll be the first term. So a sub 1 equals a number. I just wrote the number sign here because it'll actually be a number, 7, 9, 10, negative 5. The more important part is the second part to this formula. A sub n equals a sub n minus 1 plus d. So this is the current term we're trying to find. This is the previous term. What does d stand for when you're doing arithmetic sequences? So yesterday you should have watched a video that let you know that d stands for the common difference. And then also arithmetic, we know that it always goes with plus or minus. So this symbol right here is always going to be either a plus sign or a minus sign. Okay. The other type of sequence that we learned was geometric sequence. So it starts pretty much the same. A sub 1 equals a number. They have to give you one of the terms. The second part of this formula says a sub n equals a sub n minus 1 times r. So because it's times, that's what lets you know that it's geometric, because geometric is multiply or divide. And we learned yesterday that r stands for common ratio. So whatever number they happen to be multiplying or dividing by. So let's get straight to the examples below. So in the examples it says, write the recursive formula for each sequence below, then find the next three terms. So we need to write a formula that looks like this, where you have a sub 1 and a sub n, and then we're also going to have to find the next three numbers. So whatever list that we have, they want us to find three more that go after it. Okay, example number 1. So by the way, I'm not going to make you figure out what kind of sequence it is. The ones on the left are arithmetic sequences. The ones on the right are geometric. So keep in mind that number 1 is an arithmetic sequence. That means they're either adding or subtracting every single time. So from 7 to 10, as you can tell, the numbers are getting bigger. That means they had to add something. How much did they add? Okay, so from 7 to 10, it's plus 3. Is it the same number every single time? So to get from 10 to 13, how much did they have to add? Also plus 3. And from 13 to 16 is also 13. So that means that 3 is our common difference. So I'm going to circle it and then just put a D next to it. That way we remember that's common difference. Okay, so that's this part of the formula. But I also need to know what number goes here. So I need to know what a sub 1 is. And remember that a sub 1 stands for the first term. So looking at this list, what is the first term? So this is not a trick question. It's just what's the first number? 7. So that is our a sub 1. So we're just going to write this down as a formula. So I'm going to try to squeeze this in so we can see. The first thing that we need to write is a sub 1 equals a number. But in this case, our number is 7. So a sub 1 equals 7. That's the first part of it. Okay, second part is a sub n equals a sub n minus 1 plus d. The good thing about this formula is that the only thing you're going to change is d. All of this is going to stay the way it looks right now. So a sub n equals a sub n minus 1. And what did we say that d should be? So d is right here. It's the number 3. So we're going to write plus 3. So that is our recursive formula for this sequence. Okay, but now it also wants us to figure out what the next three terms should be. So I'm going to zoom in back on the sequence. Since we already figured out that the pattern is that they're adding 3 every single time, we're just going to continue that pattern. What is 16 plus 3? That's 19. Then what is 19 plus 3? That's 22. And then one more. What is 22 plus 3? That's 25. So now those are the next three terms that they wanted us to find. See, not so bad. So I'm going to move down to number 3. And we're going to do the exact same thing. So again, this is an arithmetic sequence. I already know that our first term is 49. That's our a sub 1. We're going to need that later on. But now I need to find the common difference. So to get from 49 to 42, what do you have to do? Just a hint. Look at the numbers. They're getting smaller, so you're going to have to subtract. Okay, to get from 49 to 42, you have to subtract 7. Just make sure that it's constant every single time. So to get from 42 to 35, you subtract 7. From 35 to 28, subtract 7. So that number is our common difference. Now that I have those two things, I can write my recursive formula. So remember, always start by saying what is a sub 1. For our sequence, it's 49. Okay. Then the second part of it is a sub n equals a sub n minus 1 plus their common difference. So what should go next? Minus 7. Okay, so this is our recursive formula. The next thing that it wanted us to do is find the next 3 terms. So I'm going to do 3 blanks. We need to fill those in. So now that we know that the pattern is minus 7, what is 28 minus 7? 21. And then minus 7 again is 14. And then minus 7 again is 7. So this is the next 3 terms. So this is what we have for our arithmetic sequences. Okay, so geometric is very similar. Remember, the only difference is that now with geometric, you are multiplying. So you're going to have a dot here. Okay, so look at the sequence. 128, 32, 8, 2. 128 is our first term, so that's our a sub 1. But now I want to know, how do I get from 128 to 32? So as you can see, the numbers are getting smaller. So that means that it's going to be a fraction here. So the way you figure that out is you get the second number and you divide by the first number. And now simplify that fraction. So if you put that in the calculator, remember you can use Desmos. That simplifies to 1/4. Now make sure it's the same every single time. 32 divided by 4 is 8. So that means that they're multiplying by 1/4. And then from 8 to 2, you would have to divide by 4. So again, that's 1/4. So that number is our common ratio. Remember, when it's geometric, it's a ratio. Okay, so let's write our recursive formula. Always state what a sub 1 is. So our first term was 128. Now for the rest of the formula, let me scoot up a little. We need to write it like that. A sub n equals a sub n minus 1 times r. So a sub n equals a sub n minus 1 times r. And what was our r? 1/4. So this is our recursive formula. Okay, now let's find the next 3 terms. So I'm going to do 3 blanks. So we know that they're dividing by 4 because it's times 1/4. So what is 2 divided by 4? Well, that's 2/4, and it would reduce down to 1/2. Okay, now I want to divide by 4 again. So you can put this in the Desmos calculator. What is 1/2 divided by 4? Or you can do 1/2 times 1/4, and that would give you 1/8. So from here to here, remember, we're timesing by 1/4. So let's do that again. Times it by 1/4. And that would get you 1/32. So these are my next 3 terms. And one last example. 3, 6, 12, 24. So like we said before, first number is a sub 1 because it's the first number. Now to get from 3 to 6 by multiplying, what would you have to multiply it by? Good, it'd be times 2. Then from 6 to 12, you have to multiply by 2 again, so times 2. And then 12 times 2 equals your 24. So that 2, that is our common ratio. So let's write our recursive formula. A sub 1 equals 3. A sub n equals a sub n minus 1 times 2. Now it's asking for our next 3 terms. 1, 2, 3. Okay, so since the pattern is times 2, starting with the last number that we were given, what is 24 times 2? 48. And then now what is 48 times 2? 96. And then what is 96 times 2? That's 192. So those would be my next 3 terms. Okay, everyone, that's how you do recursive formulas for sequences. After you turn in this Edpuzzle, there is a Google form on Classroom that you're going to have to fill out. It's 4 questions exactly like this one. If you have any questions on this, you can send me an email or you can send me a text message through Remind.